Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at bus ducts in Revit. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can contact our support team using the options on our website. Before I start looking in Revit, I actually want to pull up my iPad here. Right, so why are we talking about bus ducts? Bus ducts are not handled terribly well by Revit, so it doesn't really know. Revit doesn't really understand them from an electrical standpoint. So when you're modeling bus ducts in Revit, you're having to do a lot of workarounds and work that you wouldn't really expect necessarily. If you had a nice electrical BIM package, you would expect it to handle a bus duct just kind of natively out of the box. That seems like something that it should handle. Revit doesn't. Okay, so we're going to talk about how you can do that in Revit and how you can layer Design Master on top of that to help handle the bus ducts that you need to do in Revit. So before we look at what we do in Revit, I do want to share this model here, which is the electrical design triangle. And this is the way that we like to think about what you are doing in Revit to help give us a framework for thinking through how all these pieces have to be put together. And there's three sides to it. We have the single line diagram, we've got the Revit model, and then we've got the calculations. Each one of these needs to be thought about and considered separately so that you have them put together in the way that that part of the triangle needs to be put together. And then you also want to have them linked so that changes in one are being reflected in the other, so that you don't have three separate models, but you've got one model that's handling all of these. So Design Master is going to tie all these things together for us in Revit. But even when you're using Design Master, you still need to think through these three separate pieces. So we're going to talk about bus ducts. We'll draw our triangle. And we've got the single line diagram. We've got the Revit model, and then we've got the calcs. So over in the single line diagram, you're going to draw a panel, and then you're actually going to have the bus duct. There's our bus duct going up the building, and there's some panels over here that we're going to connect to. And we might have a plug here and a plug here that we connect to, and then a feeder going between them. So that's what our single line diagram is going to look like. And so that's a drafting exercise that you need to happen in Revit. Using Design Master, you want to make sure you put those pieces in so that when we make updates to our Revit model, that they happen in the single line diagram as well. But that's what you're trying to get to have happen in the single line. Over in Revit, it gets a little complicated, and there's a couple different ways you can do it. So we'll talk about all those different ways. But this is our section view. So we've got level 1, level 2, level 3 to our building here. We're going to have to put in this panel down here. There's going to be panels on the other floors. And then we're going to have to do the modeling of that bus duct. And there's kind of two levels of the modeling. There's the bus duct itself. And that is just going to be a little bit of three-dimensional geometry that you put in. It's not really going to have a whole lot of electrical information associated with it. That's for coordination purposes. So you can draft that in if you need it, if you care. If you might not care about it, you might not even draw it in, because if you're the engineer doing this, you're going to be handing it to a contractor. They're going to route the bus duct, and they don't necessarily want you routing that for them because they're going to do it their own way. But if you need to have it for coordination purposes, you have to draft it in. But realize that's going to be totally disconnected from pretty much everything else we're doing. Instead, you're going to insert some nodes in here. You might have none. You might have a little node here representing the bus ducts that you connect things. Maybe each plug is its own little node. So we'll have to think through how we model it in Revit. And there's a couple different ways to do that. So we'll talk about the different ways you can model it in Revit. And the different ways you model it here in Revit, are they going to have implications for this calculation? Because we're going to have that first panel, that MDP, and then we have these other two panels, P1 and P2. And we need to get these connected so we can do voltage drop, so we can do fault calculation. So we might have a little bus gutter, we might have a plug, we might have another plug, and these might be connected. So we're going to be, again, based upon what you put in your Revit model, you're going to have little different pieces here in the calculation model. So you need to think through what your calculation model needs to look like, depending on what numbers you actually want to pull out from this, so that your Revit model can support the calculations that you're trying to do. So these are the three pieces you need to keep in mind as you're doing your bus duct. There's no perfect way to do it because it's just a series of trade-offs and compromises depending on how much work you want to do and what you're trying to get out of it. So there's no exact one right way to do it. I'm going to talk through some of the ways to start thinking through your bus ducts and using Revit and using Design Master. So with that out of the way, I'm going to pull up Revit, and I've got the simplest project possible here. I've got my MDP. I've got 3 panels we can connect to. They're on separate floors. I don't even have a floor, but they're on the walls. The walls are on the different levels. So we're going to be making these connections. Then over in my single line diagram, I've also got that MDP drawn, and then we've got the 3 panels. So we can start talking about how we're going to make these connections. The first way you could do this is you could connect each of these panels directly back to the MDP. I probably wouldn't recommend this way because all 3 of those panels are going to end up essentially on the same circuit because the bus duct is going to connect somewhere into the panel. And so they're all coming into the bus duct, and then the bus duct goes into the panel. So they're all going to end up kind of in the same spot on the panel. So you probably don't want to do it that way, but you could if you wanted to. I'd recommend you put in at least one more node here to represent the bus duct. So I'm going to go ahead and do that. I'm going to go into systems, go into electrical equipment, and I've created just this very generic equipment node. It's a 6x6 box. You'd want to think through what you want these graphics to look like if you even wanted to show up in the 3D model, but we need to have something to connect it to. Because again, you're going to draft your bus duct if you have it in there, you might draft it. But the bus duct you're putting in is not electrical equipment that you can necessarily circuit to. So what you're connecting things to is separate from the 3D representation of the bus duct. I'm not going to go over how to actually draft the bus duct in 3D. That's really a 3D drafting challenge. There's various families out there by various manufacturers. So if you do need to draft the bus duct in 3D, Google for bus ducts, Revit. You'll find the families for drafting those 3D bus ducts. That's a fairly solved problem. There's at least other resources on that. I'm talking more about the single line and then the calculation level, and not the drafting of the bus duct itself. So we'll put in this bus duct here, or a representation, a little connection point for the bus duct. I'll select it, and we're going to call this thing bus duct. All right. So now we have a connection we can, a piece of equipment we can connect to. I'm going to take this bus duct and I'm going to power it, and I'm going to connect it to my MDP. It'll connect to a breaker. However, you need to make that connection to the panel. You would make that connection here between that node and the panel downstream. And then we can take each of these panels and connect those to our bus duct. So we now have this bus duct. I have this modeled as a panel in Revit, so we're just going to be basically connecting to the circuits. So we connect to the bus duct. All right, so we've got these 3 panels that have connections back to the bus duct. The bus duct has a connection back to MDP. We pull that up in Design Master Electrical. We run the panel edit command. So you can see how this is modeled out. We've got MDP with the bus duct and then 3 panels connected to it. So that gets our Revit model put together. Then we can come over here to the single line diagram. So we have the MDP, we have these 3 panels. We probably want to put in that bus duct. So I can run insert link. I can select that bus duct. You can see it's not inserted yet. And then we need a graphic for it. So this is then a drafting challenge. What do you want this to look like? I just want a box, really. So I'm going to do a panel. We're going to do fed from bottom. I'm actually probably going to get rid of the feeder entirely. And we'll put this in here. I'm going to put it here, and then we're going to resize this whole thing. So we put that in. It makes our connection for us. Okay. It took so long because it was actually making these other feeder connections for us. And then it also made this connection. Pretty much none of these are actually how we want them, so I'm going to get rid of them all. We're going to delete them here. When we delete these things, we're removing them from the single line. We're not removing them from the Revit model. So all those connections still exist. We're just saying we don't like these graphics. And we want to try again. We want to draft it ourselves. Okay, so we got all those pieces out of the way. We've got this bus duct. It's got all sorts of labels. We're going to get rid of all those too. All right, so now we just got this piece here. We're going to stretch it up here. And we're going to make the whole thing a little bit thinner. Okay, there's a bus duct. Now we can redraw those feeders. If you run the feeder reset, we probably can get something pretty good. I'll select this panel here. And then if we select a connection point, it'll go from there to the panel for us. I'll select the connection point here. And I will repeat that. So now we have that feeder going in. We've got the connection to the bus duct. So this is kind of what we want it to look like. We might not want a breaker here. This is really just a bus plug. So you might come in here and add and modify graphics. It might be the simplest way to do this is to select this. We're going to replace that overcurrent protection. I don't necessarily have a bus plug, but I can pull a disconnect just to demonstrate that you could put in a different graphic here. So you could choose one of our existing graphics. If you don't like these graphics, you want the bus plug to look like something else, you would need to modify the graphics that we have available. So we could put in something like this. So now we have that connection looking like that. So this is starting to look like what we'd want it to look like. So we have these feeder IDs, and they're all question marks right now. That's going to tie into the calculation section. So let's look at how we would do the calculations for this. We'll run the panel edit, pull that whole thing up. So we have these panels being fed from this bus duct. If we go down and look at these feeder sizes, they actually have feeders. Now, depending on how, you might have a feeder connecting to that bus plug. You might actually just have bus bar all the way from that bus duct running vertically in the building all the way to the panel. So if you want to model this as bus duct all the way to the panel, what you want to do is you want to take this conductor, and we don't really model bus ducts as conductors in Design Master automatically. Instead, we do have this custom option. So you would select custom, and now we're going to do a custom feeder. And we can give the callout any name that we want. So I'm going to call it a bus duct. You can specify a conduit size if it has one. This is only going to be used when exporting it to Evolve for contracting purposes. So generally speaking, you can ignore that, and the parallel runs and the feeder ID. None of that's really going to matter unless you're doing an export. The bus duct is important because that's how we're going to label it. Actually, no, the feeder ID is what's going to show up here on the single line diagram. So that does matter. So we'll call just BD, just so that it's a short name. Then we have the impedance values. These are important, and you do need to get these set right. And you'll see that it's labeled here so that you don't forget. It's ohms per 1,000 feet. So I'm going to pull up my tables here. That ohms per 1,000 feet, just so you know where that's coming from, that's from NEC Table 9. So if you go back to the back of NEC Table 9 and you look up the impedance values for a standard conductor, that's the unit of measure that they use. That's ohms per 1,000 feet. So to make it easiest to pull numbers from NEC Table 9, which is where most of your impedance numbers come from, we match our values to that so that you pull the numbers exactly as they're written. So you don't have to do any unit conversion. However, if we go take a look at a bus duct specification, it's a little bit different. So I pulled this from Eaton. This is some bus duct that they have. I didn't look in too terribly hard. So, this is just an example of a spec sheet on a bus duct. So they have here on this resistance for their whatever bus duct this is. So I'm going to zoom in on that so we can see it. They've got the resistance for the different ratings of the bus duct. They've got the X and the R values, which is what our software needs. And these are milliohms per 100 feet. So you do need to do your conversion to get that to ohms per 1,000 feet. Most bus duct does specify it in milliohms per 100 feet, but you do want to make sure that you're checking what your units are and doing the conversion correctly. So a standard milliohms per 100 feet, the conversion there, you're going to take milliohms to ohms. So you divide it by 1,000, and then you're going to take 100 feet to 1,000 feet. So you multiply it by 10. So you end up multiplying it by 0.01. So you're moving the decimal point 2 places to the left, and that gets it to work out. So this 4.38 would be 0.0438. So we can take that. Let's say we're using, we're using either the 200, the 225, 400, or 600 amp bus ducts. We're going to use these numbers here, the 0.0438 and the 0.0117. So we'll go back into Design Master and we can specify those values. And you do want to make sure you get your X and your R correct. The NEC does X first and then the R, which is actually backwards from how pretty much everyone else does it. So you'll see here it's R and then X. So it's reversed from how we're asking for it. So just pay attention to that. Make sure you get it in the right order. So the X value is actually this 0.0117, and and the R value is 0.0438. All right, so now we have the proper X and R values for our bus duct. So when we do all of our calculations that depend on impedance, we have those specified properly. We want to do the same thing for P2 and P3. I'm going to select them both. I'm going to set those to custom. So now they're all set. So now we have that bus duct in here for each of these. And if we put in a feeder schedule, we've got that BD callout, and the wire callout is bus duct. So we're not using actual wire callout, it's just called bus duct. So we might actually want to put in some more information so that's actually giving us a better specification. So we might come and say that's, a 600, or these are 200 amp panels. We might say this is a Eaton 225 amp bus duct. Whatever you want to have, you can have in the callout. So that's how you can get that labeled, and that's how it's being documented on the single line diagram as to what that bus duct is representing. And then if we go to our calculations and we run calculate, it will give us our voltage drop on each of these panels. And that is using that wire call. So since we're using that custom wire call out, the wire size isn't being filled in. So if we go take a look at these panels, you might need to customize that to include the wire call out as a parameter on that schedule, because we include it as the wire call out, but we don't actually fill in any of the wire sizes because it's really not a wire size at that point. But we do have this parameter here, the wire call out. So we could adjust this to include the full wire call out so that that gets shown. So we can go into our fields. This is a standard Revit schedule. So everything that you can do in a schedule, you can do here, including showing shared parameters. So I'm going to insert that. And I actually want to use the feeder 1 call out, not feeder 2. We'll get rid of all those extras. We'll put in just the feeder 1 call out. And now we've got all those wire sizes and those bus ducts being listed there. For the length, because that's the other part that you have to think about for your bus duct, Design Master is going to calculate the length from the insertion point of this panel back to the insertion point of this node here, which is probably going to be close enough for what we're doing, because that's going to give you essentially the length of that bus duct. You have a number of different options for this. By default, it's going to be right angles. So if we run panel edit and we look at the feeder length, by default, it's doing right angles. It's going to take in any elevation change. It's going to account for that. And then there's a wire makeup where we're making additional adjustments for the connection. For the bus duct, you might not want to do that because you don't have to make the connection into the panel, but you can adjust that here. So that's how it's getting 67 feet for that panel, 69 for the panel above it, and 78 for the other one. So that's how it's calculating that. And that's going to be coming back here. These are all essentially straight lines, so it doesn't really matter if we're using the straight line or the right angles. But if this was off somewhere else in the building, if you did right angles, it would follow the X and the Y axis of the building, which is probably how you're going to have your bus duct run. You're not going to run it at an angle through the building, so the straight lines is mostly likely what you're going to do. Otherwise, if you do it at angles, everything gets really messy when you try and actually do that construction. So what this does in terms of the calculations is this will give you the voltage drop at each of these panels. It'll give you the voltage drop here at the start of this bus duct. It's not going to give you your voltage drop or your fault values at each of these plugs. So this is where you want to think about your calculations and where you actually want to have calculated values. So as it's put together, we have a calculated value here. We have a calculated value here, basically at the end of this feeder. We don't have a calculated value here. And the question is that important or not? If you need to know what the voltage drop is at each of these plugs, we would need to model those as nodes in our system. So to do that, we actually have to have 3 more pieces in here. And we can do that. So we will put in another piece of electrical equipment. And we'll call this one plug 1. And we're going to call this one plug 2. And then this one we're going to call plug 3. Now, so we've got those 3 plugs, and now we need to adjust all of our connections because we need to make our connections. Otherwise, this is what it currently looks like. We load up, we've got what we had before, and then these 3 plugs just kind of hanging out. So we need to get these plugs connected to the bus duct, and then the panels connected to the plugs. So I will do the panels to the plugs first. And then this plug, there's actually a couple ways you could do this. We could take these plugs straight back to the bus duct. That will give us everything at each of these points. If you also want to know the load at each like little section of the bus duct itself, you could basically model each of you have the plugs connect to each other and daisy chain them that way. So it's a question of how many points do you want to be able to get your calculated values for? And the more calculated values you want to be able to see, the more nodes and connections you're going to have to make. We'll just take those plugs straight back to the bus duct. Now we have the 3 separate plugs all connected to the bus duct. And again, this is more for the calculation side. So if we run our voltage drop schedule, actually, we'll do our calculation. You can see that we now have the voltage drop at each of those plugs. So you've got the voltage drop to the MVP. It's connected, at 0 because that's where our starting point is. At that bus duct, it's essentially 0. But then at each of the plugs, we've got the voltage drop to the plug and then the voltage drop to the panel. Now, we also need to adjust those plugs so that their feeders also are using a custom feeder because, again, it's a bus duct and it's not the feeder that's being specified. So we want to check all of those, change our conductor to custom again, 7, and I believe it was 048. Let's check that setting, 0438. All right, so now those plugs have that bus duct impedance set for them as well. And then we update the calculation one more time to account for that, and then we're going to get different voltage drop numbers. And then over here in the single line diagram, because we have those extra pieces, you need to think through how you want to have this drafting happen. One thing you could do is you could come into the panel edit. You could take this plug and you could say, don't show this on the one line. And now when it's thinking about the feeder and everything, it's really thinking about the feeder between P3 and the bus duct. The other thing you could do is you could actually insert that as its own separate piece. So if I erase this here, I can then insert that plug. I'm going to do it as a disconnect. The disconnect in, and then we would draw the feeders. It's going to draw the feeders for us automatically. It's going to take a moment to do that. And it's going to be very confused about what you want those to look like. Erase all this and redraw it. And then if we don't want this overcurrent protection, we can run graphic remove, select that, and there. Now we're cleaned up. So that would be, if you have those additional plugs, you can put those in. And then we have that as a device. And so if we wanted to show the voltage drop at this specific spot, we could do that because this is now labeled with the voltage drop here. So if I go scroll down, it has the voltage drop to that plug separate from the voltage drop to this panel. All right, now there's a question. What happens if the custom feeders use the same feeder ID and have different callouts? We'll give this one a different callout. So we got the same ID, different callouts. And we'll run calculate to get everything to update. It's going to look like this. So it flags it. This BD2 doesn't actually match what's over here just because of the way it's processed, but it does kind of flag it, and you see that you've got the multiple. And this would be essentially your cue at this point to go fix this so that you give this other one a different ID. Because it's really not corresponding properly at this point, because you do want your ID to be uniform. All right, next question. If the load on panel 1 increases, can we expect the voltage drop at the other panels to increase? So as it's modeled now, it would not. And the reason for that, if we go take a look at our model, so we've got panel 1, it's just connected to this plug here and then to the bus duct. It's not going to be seen on plug 2 in this other panel. If you wanted that to happen, that's where you would actually need to daisy chain them together, and you'd need to connect plug 2 to plug 1 and plug 3 to plug 2. And that way the load at each of those is going to have the full load to each of the pieces. So we would need to, take this one rather than connecting it to the bus duct, we would need to connect it to plug 1. So then we could take this plug 3, connect that one to plug 2, And now you have all of these layered nicely so that the load from P2 is going to be seen on the other pieces. So you'll have that load being included. Next question, how do you call out 800 amp bus duct before the plugs and 200 amp downstream? So again, you always want to think through, where does that need to be documented on each of these different little pieces? So on the single line diagram, that would be some labels. But then we would want to get the Revit model and the calculation model done properly. With everything put together as we have it here, essentially here we've got the 225 amp bus, but say we want to have 800 amp bus going back. So this one would have an 800 amp bus duct. However you want to do that feeder ID. And so then you want to do the same thing for these other pieces as well. So you would need to specify each one differently with the different size in those custom feeders. And then again, pull the different impedance values, because the 800 amp is going to have a different value. So we'd need to pull in this 267 and the 99. So now we have the different impedances for the feeders to all of these plugs and the other impedance for the bus duct to the panels themselves. So that would be another reason to model it in this other way. So again, you have to think through what you're trying to model, what you're trying to get your calculations to do, so that you can model it properly and then have the calculations work out. And what that's going to have in terms of an impact in Revit and in the calculations and on the single line. Do all that, and we go take a look at our voltage drop schedule again, redo our calculation, and it's going to update everything for us. It's going to look a little bit different. And this is also going to work for fault. So if I go here and set a starting fault, we can see the fault and redo the calculation. So similar there, we're doing the calculation for the fault, same as the voltage drop, using those bus duct impedances and bus duct lengths. Any other questions on the bus ducts? Hopefully this was helpful. There's a lot of different pieces you have to get in place. And again, we're focusing on the single line drafting and then the calculation component. The actual 3D drafting is going to be something where you'll need to pull out a bus duct family and do the drafting of that. And that's more on the contractor side. The various manufacturers have those families available. They've got very extensive plugins, actually, as I was looking, for laying out those bus ducts and making them look really good and properly getting them in there for collision detection purposes. And also any other questions at this point related to our electrical software at all. So if you have other questions related to Design Master Electrical for Revit, feel free to drop them in the chat. I'll answer those now. Is there a way to set up a custom project feeder ID instead of filling out that custom information for the bus in the edit pane? There is not. So once you get into custom, that's custom at that point, and we don't have any way to pull values elsewhere. Yeah, there's really no way to do that. We could, in theory, put together some features for that. We don't have them right now. I'm not exactly sure how that would end up looking. Not to say that it couldn't be done, but right now, if you're doing bus duct, you're going to be using custom conductors and manually entering the information. Thank you for watching today's Design Master training. Contact us with questions or comments by emailing support@designmaster.biz.